Assalamu alaikum students. This lecture is about the third application of the Gauss's law, that is the calculation of the electric field between two oppositely charged parallel plates. You have studied Gauss's law as flux is equal to 1 over E naught times the total charges enclosed in any closed surface, and you have derived its equation. You have discussed it in detail for various systems such as uniform and non-uniform distribution of charges, then for the spherical distribution as well. You have derived the Gauss's law for all these systems. Then you move towards the various applications of the Gauss's law. I am just going to revise it in a very summarized form. The first application, you have studied about the electric field intensity at the interior of a charged conductor, and you have proved that the electric field intensity is absent actually. So you proved that charges can't reside in the interior of the conductor, rather they tend to accumulate themselves at the surface. We also have discussed the reason behind all this. So as a result, we received the Gauss's law as electric field is zero because the charge inside the charged conductor is actually zero. This is valid for the interior of a conductor. So the Gauss's law, this Gauss's law is modified as electric field is zero for a charged conductor, and this was the first application of the Gauss's law. Then we have calculated the electric field intensity due to infinite sheet of charges. The system was basically in open one, this one, but as we know that Gauss's law is valid only for closed systems. So what you did in this case was to modify the open distribution of the charges into a closed cylindrical shape like this, and then you calculated the electric field for that cylindrical Gaussian system, which comes out to be electric field is sigma by 2 epsilon naught. This was the value for the electric field intensity for infinite sheet of charges, and the sheet was considered as positively charged. You can also consider the sheet as negative, but I have told you before that usually we follow the convention. So as a convention, we usually represent the distribution or the collection of the charges as positive. Now the third application of the Gauss's law is, which we are going to derive today, that is about the electric field intensity due to oppositely charged parallel plates. Look, all the terms they are requiring for the system is actually included in the title of this application. So electric field between two oppositely charged parallel plates, this is a little bit different from the previous one. In the previous application, we only consider a single type of positive charges uniformly distributed across an infinite sheet of charge. This uniformly distributed across the infinite sheet of charge. But here we will consider two oppositely charged plates. One is positive, another is negative, and the uniform electric field is shown between these two plates. And of course, the electric field is always directed from positive towards negative, as you can see in the diagram. Now we have to calculate an electric field for any arbitrary point over here in this electric field. कोई सा भी पॉइंट आप कंसिडर करेंगी और उस पॉइंट के लिए आप इलेक्ट्रिक फील्ड को कैलकुलेट करेंगी. But firstly, we have to consider a Gaussian surface just like the previous two applications. So a rectangular Gaussian surface is considered for the two oppositely charged parallel plate system, and there are actually four surfaces for that rectangular systems. Look in the diagram, the dotted red line is actually representing the imaginary Gaussian surface, that is a rectangular one, and four surfaces S1, S2, S3 and S4 are associated with this Gaussian rectangular surface. So if we are going to calculate the total flux due to this rectangular shape, the mathematical equation will be the total flux will be the flux through S1, the flux through S2, the flux through S3 and the flux through S4. So this will be the total flux around the considered Gaussian surface. So now by putting the values of the flux, that is EA cos theta. So for S1 we will be putting it as E1 A1 cos theta 1, E2 A2 cos theta 2 and like this. So this equation with phi S1, S2, S3 and S4 is actually modified in this way. So now you can look at the Gaussian surface. S2 and S4 are actually perpendicular to the electric field lines. So I mean theta 2 and theta 4 is equal to 90 degree. So cos theta 2 and cos theta 4 will goes to 0. So if these two terms are 0, so the total flux will be like this. This equation is modified in this way. I have put the second and the fourth term as 0. So I am remaining with the terms only E1 A1 cos theta 1, E3 A3 and cos theta 3. Now again look at the Gaussian surface. This one, the dotted one, you can see like the S3 is out of the influence of the field. So if S3 surface is out of the influence of the electric field, so it means E3 is 0. Look, the two terms, the second and the fourth terms were 0 due to the angle, and the third term is 0 due to the 0 value of electric field. So the equation is now again modified like the total flux is E1 A1 cos theta 1 plus 0. The third term is also 0. So now the only term which is contributing towards the total flux is E1 A1 cos theta 1, or simply you can write it as EA. Now cos theta 1, I'm going to fix it as maximum as 1, and now there is a single term contributing towards the total flux, so no need to write as 1 and 2 and like that. So the total flux you are remaining with EA. This is equation 1. As you know, the Gauss's law is 1 over epsilon naught multiplied by the total charge. This is equation 2. So if you compare this equation 1 with this equation 2, you will receive EA is equal to 1 over epsilon naught the total charges. So as we are going to calculate the value for electric field, so we will be dividing both hand sides by A. So here I will be having like E is equal to 1 over epsilon naught A divided multiplied by total charges. So now look, the total charges divided by A, these two terms, this is actually providing you with the charge density sigma. We have defined it in very detail. मैंने आपको डेंसिटी की जनरल डिफिनेशन भी बताई, फिर मैंने आपको 1 डायमेंशनल 2 डायमेंशनल 3 डायमेंशनल डेंसिटीज़ भी बताई हुई हैं, और मैंने आपको जनरलाइज्ड हर टाइप की डेंसिटी समझा दी थी. सो हियर I am having areal charge density, surface charge density, the charges per unit area, and that is sigma. So electric field comes out to be sigma by epsilon naught. So this is actually the electric field we have calculated for the oppositely charged parallel plates. Here, look from this equation, we can say that electric field is dependent on charge distribution and the nature of the medium. This is the charge distribution and this is the nature of the medium. So basically it is again obeying the Gauss's law. Now if we compare the result of electric field for this two oppositely charged parallel plates to a single sheet of charges, this one, look, this is sigma by 2 epsilon naught and this is sigma by epsilon naught. So it means the electric field over here for the oppositely charged parallel plate is actually doubled as compared to the single sheet of charges, because the charges are of two types over here. So ये भी एक बहुत इंपॉर्टेंट सा रिजल्ट आपके पास जो है इसमें से डिराइव हो रहा है कि अगर आप सिंगल शीट ऑफ चार्ज के इलेक्ट्रिक फील्ड की वैल्यू को पैरेलल प्लेट्स के इलेक्ट्रिक फील्ड की वैल्यू के साथ कंपेयर करें तो आपके पास ये वाली वैल्यू जो है डबल आ रही है, क्योंकि यहाँ पे चार्जेस दो तरह के हैं और वहाँ पे आपके पास सिर्फ पॉजिटिव चार्जेस डिस्ट्रीब्यूटेड थे. सो दिस इज़ ऑल अबाउट द Gauss's third application, the calculation of the electric field for the oppositely charged parallel plates. Thank you.